Welcome to our today discussion. Today we will discuss Form 2 Physics. And in Form 2 Physics, we will start by listing all the topics which is there in Form 2 syllabus. And I have them here. The first topic is magnetism, measurement 2, which means there is measurement 1. And measurement 1 is found in Form 1. Turning effect of the force, equilibrium and center of gravity, reflection at curved surfaces, magnetic effect of an electric current, Hooke's law, waves, sound 1, and the last, fluid flow. Okay, so we will start by discussing from the first one to the last one. And I will start by the first topic, which is magnetism. Magnetism. In magnetism, we will list the areas which is to be covered in magnetism. And we have around 8 areas to be covered in magnetism. And the first area now, is properties of a magnet. Properties of a magnet. The properties of a magnet, that's the first area. The second area is magnetic field pattern. Magnetic field pattern. Magnetic field pattern. That's the second area. The last one is the domain theory. Not even the domain theory, but we will move to number 3, which is the Earth magnetic field. The Earth magnetic field. The Earth magnetic field. Earth magnetic field. The Earth magnetic field. B is the domain theory. Domain theory. D is magnetization of a magnetic material. Magnetization of a magnetic material. Magnetization of a magnetic material. F is demagnetization. G is hard and soft magnetic material. Hard and soft magnetic material. Hard and soft magnetic material. And the last one now is application of a magnet. Application of a magnet. Application of a magnet. Okay, so those are the areas now which we have in magnetism. So we have 8 areas, properties of a magnet, magnetic field pattern, the Earth magnetic field, the domain theory, magnetization of a magnetic material, demagnetization, hard and soft magnetic material, and application of a magnet. Okay, so in magnetism, that's the first topic. These are the areas to be covered in that magnetism. Okay, and we will start now from the first one, which is the properties of a magnet. Properties of a magnet. Properties of a magnet. In properties of a magnet, there is 4 properties of a magnet. We have 4 properties of a magnet, and we will start with the first one. The first one is called the poles of a magnet. Poles of a magnet. Or sometimes we call it polarity. The poles of a magnet, which is the polarity of a magnet. If you take a bar magnet, for example, and I have a bar magnet here, this is what you call a bar magnet. If you take this bar magnet and you dip it into iron filings, you will find that the iron filings will cling mostly at the end of the magnet. The iron filing will cling mostly at the end of the magnet. But at the middle, it is only few which will cling there. But at the end of it, most of them will cling. Like this one now. If you have a bar magnet, this one is a bar magnet, and you dip that bar magnet into an iron filing. You will find iron filing will cling mostly at the end here. We have so many iron filing clinging at the end of the bar magnet, but only few at the middle. So which means now, this point now, the end of the magnet where the iron filing clings mostly, it means the magnetic field at the end of that magnet is strong. So that point now, which is having strong magnetic attraction, we call it the poles of the magnet. So the poles of the magnet is the end of the magnet here. So we have poles of the magnet. We have this point and that point. And in that poles of the magnet, we have north pole and south pole. So then, if this side is north pole, the other side will be south pole. So we have two poles of the magnet, or the polarity. There is north pole, we have north pole, and south pole. South pole. So those are the polarities of the magnet. I have said like this: if you take a bar magnet and you dip that bar magnet into iron filing, you will find that the bar magnet, the iron filing will cling mostly at the end of the magnet. Those points which is having strong attraction, we call it the poles of the magnet. Okay, the second property now, that one is the first property. The second property is directional property. Directional property. That's the second property of a magnet. Directional property. If, for example, we take a bar magnet. If, for example, we take a bar magnet, and I will show you, I have a bar magnet here, and I have a thread here. If you take a bar magnet, and then we take it a thread like this. We take a thread like this one here. So let me demonstrate this one a bit, which we have about directional property. Directional property. Directional property. Okay, if I take a bar magnet like this, if I have a bar magnet like this, and I make this bar magnet to swing, if I make the bar magnet to swing like that, and you leave it to swing in a free air, you will find that this bar magnet will swing, but finally will rest facing roughly to the north and the south of the earth. If you make this bar magnet and make it to swing like that, that bar magnet will swing, but finally will rest facing roughly to the north of the earth and the south of the earth. The point now which is facing to the north of the earth is called the north pole. The point which is facing to the south of the earth is called the south pole. Okay, so this one now is what we have. If you take a bar magnet and then you suspend that bar magnet like this, if you suspend it, and then you make it swing, that magnet will swing but roughly face north and south of the earth. The point which is facing the north of the earth is called the north pole, and the point which is facing to the south of the earth is called the south pole. So we have two polarities of a magnet. There is a north pole and the south pole. So that one is now the second property of a magnet. And remember that I say we have around 4 properties which we discuss. The first one is the force of the magnet, second is the directional property, and we are in that one now. We are in that property. We are in that property. The that property is what we call magnetic That's that property of a magnet. Magnetic materials are materials which are attracted by the magnet. So we will start by this one. Magnetic. What is a magnetic material? Magnetic material. Magnetic material are material which are attracted by the magnet. What are some of the examples of the magnetic material? The first one now, examples. We have iron to be the magnetic material. We have steel to be the magnetic material. We have nickel to be the magnetic material. We have copper to be the magnetic material, and so many. We have so many magnetic material. So then, magnetic material now, we have said, it is a material which are attracted by the magnet. And you will find also that, even though these ones are attracted by the magnet, but you will find that some of these ones are strongly, even though all of them are attracted, but some of them are strongly attracted by the magnet. The one which is strongly attracted by the magnet is called ferromagnetic material. Ferromagnetic material. Ferromagnetic material. What is ferromagnetic material? These are materials which are strongly attracted by the magnet. These are material which are strongly attracted by the magnet. So I have said magnetic material are material which are attracted by the magnet, and we have listed some examples. We have around 4 here, and in these examples you will find that some of them are strongly attracted by the magnet. Those ones which are strongly attracted by the magnet are called ferromagnetic material. What are examples of ferromagnetic material? Examples now. Examples is iron, nickel, copper, and their alloys. So those are ferromagnetic material. Okay, so then tunaingia, so what is non-magnetic material? Non-magnetic material now. Non-magnetic material are materials which are not attracted by the magnet. Are material which are not attracted